Hey class, Mr. Angie here. For today's lesson, we're going to be taking a look at section 10.1, which is going to do with scatter plots and trend lines. Now, for today's lesson, we have two learning goals. And our first learning goal for today is that you will be able to draw a scatter plot and construct a line of best fit. And you will be able to determine an estimated correlation of the data and predict outcomes using scatter plots. Now, before we jump into our stuff for today, I just want to make note that section 10.1 is the only section we're going to do for module 10. So we're going to combine modules 9 and 10 for our quiz. That means that this is the final section for the module 9-10 quiz, and that you should be expecting a quiz upcoming soon. So just something to make you aware of and just to let you know. And then I also want to note that section 10.1 is the final section for Algebra 1A. So you have made it to the last and final section of this trimester. I just want to say thank you guys for listening along and taking the time. I hope it has been helpful. And we've made it to the end. So congrats. Let's go ahead and finish our final lesson for trimester for Algebra 1A. So with that said, we are going to take a look at scatter plots today. So two variable data is a collection of paired values such as measurements of air temperature at different times of the day. One method for representing two variable data is a scatter plot. A scatter plot is a graph of points with one variable plotted along each axis. So that means for the x-axis, you could plot the time of day, and for the y-axis, you could plot it for the air temperature. Now, a recognizable pattern in the arrangement of points suggests a mathematical relationship. So if we notice a pattern occurring, then we can talk about the mathematical relationship that occurs for that situation. Now, one way that we're going to talk about a mathematical relationship is through correlation. So, a correlation is a measure of the strength and direction of the relationship. The correlation is positive if both variables tend to increase together. So, we have a positive correlation if we look at the graph going left to right, if it goes up. Going left to right, if our graph goes up, that's considered a positive correlation. A negative correlation is when one increases and the other decreases. And as we look going left to right, if that graph goes down. So if our graph goes up, left to right, it's positive. If our graph goes down, left to right, it's negative. Now, no correlation is if the change appears to be unrelated, meaning there's no pattern that we can discern or decipher from the graph. So these are three examples of scatter plots. Notice how they are not in one exact straight line, but they can be plotted wherever. It's our job then to determine the correlation, and then if we can use that correlation to predict outcomes. So, three different ones: positive, negative, no. Positive, it increases left to right. Negative, it decreases left to right. And no correlation, there's no pattern at all. So, with that said, we can kind of break down correlation a little bit more detailed. I'm going to move this up so we can talk about the correlation coefficient. So, a way to quantify the correlation of the data is with a correlation coefficient, which would be denoted by R. The correlation coefficient varies from -1 to 1. The sign of R corresponds to whether the graph is positive or negative. So if our number is positive 1 or positive 0.5 or something, okay, there's not going to be a negative. If we have a negative correlation, then it needs to have a negative in front of the number. Now, strongly correlated points look more like points that lie in a straight line. So this is a strong negative correlation, and this is a strong positive correlation. When we talk about strong correlations, those numbers are closer to 1 or -1. Now, 1 would indicate that it is all on the line. So like 0.9 would indicate close to 1, but not exactly 1. So the stronger the correlation, the closer it is to a line, the closer that number should be to 1 or to -1. Weakly correlated points are closer to 0. So like 0.5, -0.4, 0.3, and such. So like these two graphs. The two on the left are strong negative and strong positive correlations. So these ones should be close to -1 and +1. These two on the right are weak positive and weak negative correlations. So these should be between 0 and 1, and 0 and -1, being closer to 0, so like 0.5. So, with that said, for example 1, we're finally going to get into our example. For example 1, I want you to go through and figure out, for the following scatter plots, state the correlation and estimate the value of R. So between -1 and 1. The homework might have you do this by going through and using -1, -0.5, 0, 0.5, and 1. Now, first thing we need to do for example 1 is go through and state the correlation. So is it positive, negative, or no correlation? If we look at our first one, okay, looking at the graph from left to right, is this a positive correlation? It is, because going left to right, it goes up. So this is a positive correlation. If we look at our second graph, going from left to right, does this graph go up, down, or is there no pattern? The graph in general is going down, so this is a negative correlation. If we look at our third graph, okay, going left to right, does it go up, down, or is there really no discernible pattern? There's really no pattern to this one, so we're just going to say that this has no correlation. And then for our last one, going left to right, this one's going down, so that's going to be considered a negative correlation. So we've gone through and determined the correlation for each of these. Now all you have to do is just estimate the value of R, so between -1 and 1. If we look at the first one, okay, this is a very strong correlation, so that means that this is going to be close to 1, and for my estimating purposes, I would say about 0.8. If we look at this one, it's not terribly weak, but it's not real strong like this one is. So I would say that it's going to be close to 0.5 or -0.5. And I'm just going to estimate it as -0.5. Okay, because the data is fairly weak. It's not strongly close together. It's fairly close, which tells us a pattern, but it's not super tight together. So I'm going to estimate -0.5. Again, negative because it's a negative correlation, and 0.5 because it's kind of a weak data set. Because no correlation, our value for this one is going to be 0. If there is no correlation for our scatter plot, then we're just going to use 0 as our correlation coefficient, so our value of R. All right, and then the last one, so we have a negative data set, and this one is pretty strong, so we're going to say this is close to -1. And I would estimate it at about -0.9 for the data set. So that is how you go through and determine the correlation, whether it's positive, negative, or no correlation, and then estimate the value of R between -1 and 1 based off the data in the graph. So that is how we do example 1. Next, we are going to talk about constructing scatter plots and then also talking about lines of best fit. So, move it there. So, a line of best fit is a line through a set of two variable data that illustrates the correlation. There are many ways to come up with a line of best fit. This lesson is going to use the visual method, where we're just going to use a straight edge, a ruler, and we're going to draw the line that the data points appear to be clustered around. So we're going to try to draw through the middle part of the data. It is not important that the points actually touch the line, instead that the line should be drawn as straight as possible through the middle of the points. Now, you could do this in a very technical way, and actually find the equation of the line by going through and taking 2 points from that line and going back to module 6 and writing the equation for a line. For today, we're just going to worry about constructing a scatter plot and then drawing a line of best fit. So, example 2 is going to have us do just that. So we need to go through and construct a scatter plot for this data and then draw a line of best fit. So if we go through, so if x is 100 and y is 0.2, so 100 and 0.2, 200 and 0.48, 300 and 0.55, 400 and 0.66, 500 and 0.68, 500 and 0.72, 600 and 0.76, 700 and 0.78, 700 and 0.79, and then 900 is at 0.77. So I have a scatter plot that looks something like this. We need to go through and draw a line of best fit for this data, and you're just going to kind of estimate about where you think it would go. So we're going to try to find the middle of the data, and I'm going to draw my line of best fit to be about there. Now, if it wasn't for these 2 points, I would draw the line going right through those points a little bit more, but because these 2 points kind of pull it down some. And that is how we go through and construct a scatter plot and draw a line of best fit for the data. Now, you would do the same thing for parts B, C, and D. I'm just going to run through one more with you guys, and then you can always reference my completed notes for the other 2. So I'm actually going to go through and do part D. So I'm going to leave part B and C for you to do. Like I said, they are done on my completed notes if you want to reference those ones. So let's go ahead and take a look at D. So again, for D, we need to go through and construct a scatter plot. So first, we're going to go through and plot our points. So at 100, it's 270. 200, it's 220. 200 is at 270 as well. And at 290. Then 200 is also at 300. 200, or no, we're now at 300 is at 250. 500 is at 160, so 500 is at 160. 500 is at 170. 500 is at 180. 500 is at 200. 700 is going to be at 150. Or sorry, 700 is at 140. And then 150. And then 900 is at 90 and 140. So 900, so we're at 90 and then 140. Okay, so we have our scatter plot that looks much like this. This one would be a negative correlation, much like part A was a positive correlation. So if we're going to go through and draw our trend line or a line of best fit, I would say that our line would kind of be about there. So I'm going to go through and construct our line of best fit. It's going to go through that. And would you feel like that is a good line of best fit for this scatter plot? I hope you say it is, because I would say so as well. So that gives us another example for how to construct a scatter plot and then draw a line of best fit for the data. So scatter plots, you're just going to go through and plot the points. Line of best fit, you're going to try to draw a line that goes through the points that are kind of clustered together that kind of draws the trend. You're going to try to draw through the middle of the points. It doesn't have to touch all the points, but just as many as possible. So with that said, that is how you do example 2 for constructing a scatter plot and then a line of best fit. So with that said, we are going to move on to section or example 3, and we are going to talk about how to use a line of best fit and that equation of the line of best fit to make a prediction. So example 3 wants us to use the linear model given in each situation to make a prediction and classify the prediction as interpolation or extrapolation. So for part A, for example 3A, it states that Amelia opens a car wash and keeps track of her weekly earnings. And the linear model is given below for this y equals 500x plus 1010. So how much money might Amelia hope to earn 6 weeks after opening if the trend continues? So if you get to the problems on the homework where they're going to give you a linear model with an equation, y equals something, what you are going to do for these problems is you're going to take that equation and you're going to take, based off the follow-up question, the number, and you're going to plug it in for x. So when this talks about how much money might Amelia hope to earn after 6 weeks, that means we're going to take that 6 and we're going to plug it in for x to figure out how much she could hope to earn if that trend were to continue. So we're going to take 580 times 6 plus 1010. So if we do 580 times 6, we end up with 3,480. And then we're going to add 1010. and we end up with 4,490 as our answer. So, how much money might Amelia hope to earn after 6 weeks if the trend continues? She should hope to earn $4,490 6 weeks after opening the car wash. And that is how we go through new example 3. So again, when you get to the problems on the homework where they ask you to use the linear model given in each situation to make a prediction, okay, you're going to use the equation and you're going to plug in the number for that. Now, what this is doing is it would be the situation would be something like this, where it would give you a scatter plot and you would draw the trend line, and then that equation, that y equals 500x plus 1,110, would be like an equation for this line. So you're using that equation of this line to make a prediction for what they should earn after 6 weeks. So all I'm doing is just not having us go through and draw the scatter plots, draw the line, write an equation for the line. I'm just having you go through and use the equation of the line of best fit to answer the question. All right, for part B, so we have Eddie is training for a race, and let me start over. Eddie is training for a race by running a mile each day. He tracks his progress by timing each trial run. He recently completed his 8th trial run, and the linear model for his time is given below. So what mile time does Eddie expect for his next run? So we're going to use this equation to help us figure what he should expect to run for his next run. Because he has already run 8 trials, that means I need to plug 9 in for x, because his next trial run is his 9th trial run. So to figure out what mile time he should expect, we're going to do y equals negative 0.157 times 9 plus 8.38. So we're just going to go through and calculate this then. So negative 0.157 times 9 is going to give us negative 1.413. And if we add 8.38, we get 6.967. So for his next run, he should expect to run a 6.967 mark for his trial run. Again, this would be the equivalent of if you had a scatter plot like this where his time or his runs are getting faster and faster, so they're going down in terms of time it takes. Taking that line of best fit, writing an equation for it, and then plugging in for the 9th trial what it should be. And in this case, it would be 6.967. All right, for the last one, for part C, it talks about use the model constructed for this one. So we need to use the model constructed to predict the average annual temperatures for Austin, Texas, which is at 30.3 degrees north, in Helsinki at 60.2 degrees north. The linear model is given below. Y represents the average annual temperature, and X represents the latitude for each city. So that means we need to take this equation and we are going to plug in 30.3 to figure out for Austin what the temperature should be. and we're going to take 60.2, plug that in for x to figure out for Helsinki. So we have to do this twice. So for Austin, it's negative 1.1x. So that's negative 1.1 times 30.3 plus 106. And that's going to tell us the average annual temperature for Austin, Texas. And then to figure it out for Helsinki, or Helsinki, sorry. For Helsinki, we're going to take the 60.2 and plug it in for x. So it's negative 1.1 times 60.2 plus 106. So what you're going to do then is use your calculator. So if we do negative 1.1 times 30.3, we get negative 33.33 plus 106, and that is going to give us 72.67. And then for Helsinki, we're going to take negative 1.1 times 60.2, so that gives us negative 66.22 plus 106, and that is going to give us 39.78 for the average annual temperature in Helsinki. So again, all we did was just use this equation, use the number they give us to make a prediction for what the average annual temperature for these two cities would be. And that is how we do example 3. All right, last one is example 4, and our final example for Algebra 1A. So example 4 is going to have us use the graph and the line of best fit to make a prediction for each situation. So this would be similar to example 3, but instead of using the equation of the line, we're just going to use the line to help us make a prediction. So what we're going to do is they have already provided us with the scatter plot and the line of best fit, so we don't have to worry about graphing the scatter plot and drawing the line of best fit. All we have to do for this one is use the line of best fit to answer. So if we look at A, it says estimate the average annual temperature when the latitude is 60 degrees north. So latitude, so we're going to go to 60 degrees, which is going to be right here. If we go up to 60, it's going to be at this spot on the line. So if we go across, we should estimate that the average annual temperature for 60 degrees north should be about 40 degrees Fahrenheit. And that's how you're going to use it. So that is how you would use a line of best fit to make a prediction. So if we do that for part B wants us to estimate the boiling point of water at an altitude of 6,500 feet. So if we go to the altitude of 6,500 feet, it's going to be right here. So that's going to hit the graph right about there. If we go across, it's going to be at about 200 degrees Fahrenheit. So the boiling point of water at an altitude of 6,500 feet is 200 degrees Fahrenheit. All right, and then last one. So for part C, it says estimate the height of the tree after 6 years of planting. So year 6 of planting is going to be right here, and that's going to hit about there. And we would say that's about 11 feet tall. And that is our answer. And that is how you do example 4 on using the line of best fit. So you just look at the graph, you go to the point on the x-axis that they're talking about, go up until you hit that line of best fit from that point, and then you're going to go across to the y-axis. So again, take what they want you to find. So 6 years, so we're going to go over on the x-axis to 6 years. We're going to go up till it hits the line, so it's here, and we're going to go over to the y-axis to see what that should be. And that's how you use the line of best fit. And that is it for our notes on section 10.1, dealing with scatter plots and trend lines. So we've talked about looking at a scatter plot, determining if it has a positive, negative, or no correlation, and then also estimating that correlation coefficient from -1 to 1. We've also looked at how to construct a scatter plot and draw a line of best fit. We've also talked about how to use the equation of a line of best fit to make a prediction. And then we've also talked about how to use the line of best fit to make a prediction. So, with that said, that is it for our notes on section 10.1. And that is it for our final lesson for Algebra 1A for this trimester. So again, congratulations, you made it to the final lesson. Thank you for listening over these different days and throughout the videos. As always, if you have any questions over scatter plots or trend lines, just let me know via email or next time you see me, and I'll be more than happy to help. As always, reference the completed notes as you work on the homework, and let me know if you need any help. Otherwise, that is it for today's lesson. Thank you guys for listening. I hope you have a great rest of your day, and I'll talk to you guys later. All right, bye.